everyone can relate to cooking a meal. How it would be nice to have an app that tells you what side dish to make based on the main course you're preparing.
That's where LLMs come in. We're discussing today how large language models, LLMs, like those used in AI, actually work. It's a non-technical explanation, so don't worry if you're not a computer whiz. The first step in creating such an app is teaching the computer to think about meals as data. This involves feeding it a lot of data about what types of dishes people have paired together in the past.
By analyzing this data, the computer can start to understand the relationships between different dishes. For example, it can learn that Caesar salad and caprese salad are often paired with Italian dishes, even though it doesn't know anything about the taste or ingredients of these salads.
That's correct. The computer starts to categorize dishes based on the patterns it observes in the data. It clusters similar dishes together and places them close to each other in what the author calls meal space.
Here's where it gets interesting. The placement of dishes in meal space is not random. There are underlying hidden mathematical patterns that determine where each dish is placed relative to others.
This is where food arithmetic comes into play. By understanding the coordinates of different dishes in meal space, the computer can perform calculations and determine what dish would be the most optimal addition to a given meal.
In essence, the computer can tell you which dish to pair with your main course using these mathematical patterns and calculations. It's like having a virtual chef to guide you in the kitchen.
This concept can be applied to language as well. The author explains that by replacing meals with sentences and dishes with words, you can create large language models that can generate text based on patterns and relationships between words.
The first step is training the language model to understand the relationships between words by analyzing a large data set of human-written text. The model learns that a word is categorized by the company it keeps.
Once the model has learned these relationships, it can predict the next word in a sentence based on the patterns it has observed. This is called next word prediction. So if you prompt the model with a phrase like, "Tell me you love me," it will predict that the next word is likely to be I, and then love, and so on.
This process continues with the model generating text based on the patterns it has learned. It's like a virtual writer coming up with sentences based on what it has seen before.
What's fascinating is that this technology, even though it seems complex, is built on some simple mathematical concepts and a lot of training data.
Just as recipes cluster dishes mathematically in an invisible meal space, words occupy locations in a conceptual lexicon.
Analyze enough text and models discern these word patterns. Soon language relationships emerge. Generate a phrase and AI predicts forthcoming words, virtually writing itself. Behind the eerie eloquence lies elementary math and lots of data.
In truth, we've merely trained language algorithms to echo our own human expressions. But as models grow smarter, will their virtual voices one day speak deeper truths than our own?
Do us a favor and please hit subscribe. And maybe even tell a friend. Now let's keep the discussion going, taking a look at